We used to write JavaScript code that looks like this. This function takes an input array data structure and a target as its parameters, and then returns an array with the index for the target within the data structure if it exists. Otherwise, the function will return a string of not found. The code for the existence checking obviously is within this if check. You might see this type of code within your company's or organization's code base or within older open source projects. It is accurate to say that this function has an O of n time complexity because the code scans the input array once here and then it scans the input array a second time here. O of n for this first scan, O of n for the second scan, give us O of 2n, but we know that we drop the constants. And overall, it still results in O of n, but we're doing two passes here and here. And then there's the matter of the higher order functions of reduce and include, which has overheads in them, which will cut down on our performance time as well. And even if you encounter really old JavaScript code that's using for loops or whatever loops they're using in lieu of these higher order function, the code is still making two passes or two scans for the input array. Now, technically, there's nothing wrong with this function. It'll work if you're expecting, say, a couple of hundreds elements within this input array. But what happens if you get 200,000 inputs or even larger data sets in the context of machine learning pre-processing, which is very performance critical? Or if you are training your local large language model to generate JavaScript code that will handle multiple situations and scenarios. Let me offer a more efficient approach to the above function with regards to checking for the existence of elements within an input array. First, we will generate our own array literal instead of using reduce, and we will remove the include function, and then we will loop through the input array searching for our target. Now this loop and search through the input array is still O of n in what is considered as asymptotic, meaning that as the size of the input grows, so does the time. However, I am replacing the second scan that I'm doing up here with the include with this ternary operator down here. So in other words, the decision whether to output not found or the output array with the index of the target in it is decided by this ternary operator on line number 26. So let's examine what this ternary operator is doing. So if the length of the output array is at least 1, then which is to say that if we found the target within the input array, we will push the index in here, right? So then if this is true, then we will return the output array with the elements, with the index of the target element in it. Otherwise, we will return not found. So therefore, we are only scanning the input array once, right? Because up here, no matter what happens, we are going to scan the input array twice. Whereas down here, we are only doing it once. And they can only, if we're searching for one index, then this, if we found a target, the size of this output array will only be one. And what if we wanted to find the low and high range within the input array? Again, with this approach, it's not wrong, right? It's not wrong, but it's scanning this input array twice. And of course, I wrote this function here to simulate really old JavaScript code in some of the open source project, and even some of your company's code bases, older code bases, um, in the case where they're still using ES5 before the existence of ES6, where they're using for loops instead of higher order function. Again, we're still looping to the input array twice. So the solution for this is essentially the same. We create our own array literal and then we loop through the input array just once. And then we check for the existence of elements inside of the output array via this ternary operator on line 24. Now, if you notice here that I've cached the length of the input array in this len variable. This is, you might have seen this in the while, it's a common practice. In modern JavaScript, caching the input length will return a very small time saving, very small. But the way that I see it, if you're working with massive data set for machine learning, pre-processing, then every little thing counts, right? Every little millisecond counts. So therefore, I went with this approach. Okay. All right. Hopefully that helped. Um, if you found this video useful, please consider subscribing. If you're not already a subscriber, it doesn't cost you anything. Otherwise, thanks for watching. I'll see you next time. Bye for now.